Now in this lecture we will look at fractional knapsack problem which can be solved using grid algorithms. Now before solving this problem, let's identify what's a fractional knapsack problem. The knapsack problem is a problem in combinatorial optimization. Given a set of items, each with a weight and value, determine the number of each item to include in a collection so that total weight is less than or equal to given limit and the total value is as large as possible. It derives its name from the problem faced by someone who is constrained by a fixed size knapsack and must fill it with the most valuable items. This problem often arises in resource allocation, where the decision makers have to choose from a set of non-divisible projects or tasks under a fixed budget or time constraint. So what does this definition mean? So let's make it more clear. So here you can consider a knapsack as a box. So this box has a limit of at most W weight. This means that if our box can take 30 kg, we cannot fill it with 31. But this 30 kg has to be with the maximum value. So here the idea is we are given some items which have weight and values, and we have to take only few items from these given items such that the value of these items that we put in a knapsack is maximum. So let's make things very clear using a real life example. Now imagine we have three different types of box over here with valuable accessories. And we are given a knapsack which is this box over here. So this box limit is 50 kg. So we have to fill these valuable accessories from these boxes over here to this box in which the value of these accessories will be maximum. And here we have an assumption that the items can be broken down into fractions. That's why it's called fractional knapsack problem. So as you see clearly here, each type has weight and value associated with it. And the capacity of our knapsack, as we mentioned, is 50. This means that we have to take 50 kg from these boxes over here, but the value of this accessories must be maximum. For example, if we take first two boxes, which is blue and red, the value of accessories in our box, in our knapsack, will be 220. Now the question is, can we improve this? The answer is yes, because if we use greedy algorithms, we can improve this value to 240. Now here we are taking this green one, which is the value of the 60. Then we are taking this blue one, which is the value of 100. Then we are taking 2/3 of red one from here, then it becomes 240. Now you might be interested how we find this solution. So we have found this solution using greedy approach. Now let's see how this is working. Here the first thing that we are going to do, we need to find out which of items among these three has the maximum density, which means that per 1 kg, which item gives us maximum value. So to find the density of this box over here, we need to take value divided by kilogram. So it will give us 1 kilogram's value. So in this case, in the case of blue, it gives us 5. In the case of red, it gives us 4. And in the case of green, it gives us 6. Now the next thing we are going to do after calculating these densities, we have to order them in descending order based on density. So if we order them, it becomes like this. So after ordering them, we will take the first, which is with the highest density, because in this case the value is highest. So we are taking green, that's why we put 60 over here. Then we are taking blue, that's why we took 100 over here. Now if we take blue and green, the kilogram becomes 30, because 10 plus 20 is 30. So here 20 kilogram left to be filled this knapsack over here. So we are taking the 20 kilogram from this red one. So if we are taking the 20 kilogram, so we have to multiply 20 with 4, so it becomes 80. So the total result becomes 240. So hopefully everything is clear about this example. So I hope you have understood the logic behind fractional knapsack problem. Now based on this explanation over here, let's see how the algorithm of fractional knapsack problem looks like. Now here, the first thing that we are going to do, we are calculating density or the ratio of each item. This is calculated by dividing value to kilograms. So we are calculating the density. Then after calculating density, we are sorting these items based on this density over here. So after sorting, We are taking the items with the highest ratio sequentially until the weight allows. Then we are adding the next item as much as we can. So this is how our algorithm looks like. Now in the next lecture, based on this algorithm, let's create Java program which calculates fractional knapsack problem successfully. So see you in the next lecture.